Hello! After watching this video, you will understand how the model space scales and layout scales work and will never have to struggle with annotations, hatches or line types not looking how you want it in the printable layout. You will learn about this while we explore the drafting scale component. It can be found in the Rhino 8 tabs drafting section. Let's get to examples. We have different scales for model and layouts because we are currently in a transition period between paper drawings and full information modeling. With modern CAD software, we can model in perfect one-to-one scale so that a column that is 3000 mm tall will be 3000 mm tall in the 3D model world. But as we are still stuck with paper drawings, we will have to be able to fit it to a paper for someone to make the column. This is why the line types or texts cannot be in the same scale in both, because a 3.5 mm text on paper is pretty tall, but in a model of a 50-story high building it is impossible to even see. Now let's say you're facing the following dilemma. You have created some hatches and dimensions and you will edit them in the model space to look how you want. And when you have finally reached the point where you're satisfied with your model, you go to print it and it doesn't quite look how you wanted it to look. Now, why do the annotations look the same as they do in the model? This is because the detail view has its scale value set to 10, which happens to be the same as the model space scale on the annotations. In Rhino, when you create an annotation, you will have a height value for the text. This is now 3.5 mm, so no matter what I set the model scale to be, this annotation will always be 3.5 mm tall in the layout view, as long as the annotation layout scaling is set on. Let's open Grasshopper and dive deeper into this. This is the drafting scale component. You can toggle the annotation model scaling, the annotation layout scaling, and hatch scaling with the first three inputs. You can also edit the hatch scale and the line type scale. So we go back to the model, and this is the annotation that we changed the model space scale to 1000. If I toggle the annotation model scaling off, none of the model space scalings will apply. This also makes it hard to read this smaller text, because this is now 3.5 units tall. If we go back to the layout, everything is still set to 3.5 mm in paper space. So changing the model space scale will help you see how your annotations actually are going to look in the printed view. Now, why you might want to be able to toggle the model space scaling off. If you're working on a model that has a lot of views of different scales created from, and some of them have very large model scalings, they are going to block your model view when you're actually working on the model. Let's move on to the annotation layout scaling. By default, this is set to true in Rhino. You can find this by navigating to the options menu and clicking on the annotation styles. Here you can toggle these options on and off. Now, what the annotation layout scaling actually does. As we discussed, Rhino is going to keep the text height at the height that is set to the annotation. So no matter how far or close I will zoom to, this text is always going to be 3.5 units high in the layout view. But if I toggle the layout scaling off, I can now actually zoom in and out on this annotation. As you see, it's currently not 3.5 mm tall in the paper. Let's move on to the hatch scaling. Now, before we set the scale value of these hatches to 50 to get them look how we wanted. And we found out that they do not look how we wanted in the paper view. If we go back to the model view and turn the hatch scaling off, nothing happens here. But as we go back to the layout, we see that the hatches will now have updated to look exactly like in the model. Now remember that when the hatch scaling is turned off, there is not going to be any scaling, so if you zoom, your hatch will be exactly the same scale as it is in the model. With scaling on, these small rectangles are always going to be the same size, no matter how deep you zoom it into. This can be observed by looking at the cube on the left and comparing it with the box on the right. Now let's see how the hatch scale input affects our hatches. I have currently set all scales to 1, and when I begin increasing the scale, my hatches start to look different. Now remember that the drafting scale component is going to scale this hatch scale again, so it's a multiplication. If I set this to 10 and this hatch scale to 10, the actual scale of this hatch is now 100 instead of 10, and these hatches have the scale of 10. Now, if you want your hatches to look a certain way, the easiest way to do it is to go into the layout view and edit the hatch scale there. This way you will always know what your hatches are going to look like when they are printed. Let's say I want this scale to be 50. Now I go to the model view and see that this does not look like anything that I have on the layout. You can use the drafting scale component to change the model space hatch scale factor so that it matches the layout. If we adjust the model hatch scale to 10 to match the viewport, we can see that the patterns match again. The same exact logic applies to the line types. Here I have a line type with the scale of 1. If I go to layout, the line looks like this, which is what I want. So to preview this correctly in the model, I can go ahead and change the line type scale to match the viewport scale. Now my lines look the same as in the viewport. The basic concept is to define how you want an object to look in the layout and then adjust the model space scale to match the layout scale. This way you can kind of preview the layout view in the model space. That is all for now. If you learned something, hit the like button and subscribe to the channel. I'll see you on the next. Thank you for watching.